I'll hand it off to Dan Cox from NHERI, who is going to talk about data sharing experiences at NHERI Wave Research Laboratory at Oregon State University. So take it away, Dan. Thank you.
Thank you very much. Hopefully audio is okay, and I'll start to share my screen. But thank you so much for the introduction. Happy to talk about some of our experiences. And I think in this talk, moving also just a little bit past the initial storage of the data, but how do we actually get it published? That's a really important piece for us as a shared use facility, is getting the data out to people. And we've had a lot of experiences in how to do that and who's responsible for doing that. So that's kind of the big takeaway for me, is how do we get the users of our shared use facility to publish their data? And a huge thanks to the contributors that you see on the screen. These were some of the users and people who support our facility. And a huge acknowledgement to NSF for supporting us for these. We're in year 10 of our 10-year cycle, so it's pretty exciting. It's a very large network of facilities. We have one central storage place that's designed safe at UT Austin, but you look around the circle, there are so many labs. So I'm going to talk about the one that I work for here at Oregon State University, but what I'm talking about today is replicated by several labs all over the country. We're a distributed center for natural hazards engineering research. So the hazards are typically earthquakes, tsunamis, hurricanes, tornadoes, that type of stuff, and mostly the impact on the built and natural environment. So I'll just talk about these two pieces today, but again, this is being replicated so many places. This is our facility. Sorry for the blurriness of our slide here, but this is out here in Corvallis, Oregon. We have two large facilities. These are the largest in the country and top 10 worldwide for studying phenomena related to the coastal ocean, the nearshore coast. One is a flume. It's like this long channel, if you will, filled with water. We have WaveMaker at one end, so we reproduce the wave climate and currents, things like that. And then the second one, the lower left, that's a basin. And that's, if we want to look at three-dimensional effects, similar to what we're seeing in the screen here. So this was a photo from Hurricane Sandy, and you see a lot of damage and loss to the built environment. So that's typically what the researchers come to us to study. I'll just show you a couple more slides of the phenomena. This is a hurricane that made landfall in 22. You can see the water coming in, big storms, waves, structures, all this crazy stuff going on. And they want to reproduce that in our laboratory at different types of scales. So this is one example of what we do. Researchers come in, they're always a unique project. So we don't just have in situ data that just sits there 24/7. We're setting up experiments, we're taking them down. We do about 6 to 12 experiments a year, depending on the size of each experiment. So these are all unique. We spend a lot of time with the PI, usually at least 12 months out, designing their experiments co-designing their experiments with them. Here's an example from Andrew Kennedy and his team at University of Notre Dame. So this is simulating that photograph that you saw from New Jersey. These are representations of buildings that would be impacted by a hurricane. And inside the silver boxes, for example, are lots of sensors to measure how that building would respond when the hurricane hits. And then also really hard to pick out in the picture, but there's lots of instrumentation in the water to measure what the forces would be of the hurricane, how fast the water is moving, how high the waves are. Lots of cameras that we use. Every time you touch the water, you stir it up. You don't like to do that. So we spend a lot of time with remote sensing, optical measurements, LiDAR, and things like that. It's a graphic to show you what's going on. So reproducing that hurricane. Other researchers come in and they're structural engineers, for example, studying the wave impact on the buildings themselves and how those buildings are destroyed during the event. So here's a picture of just the surge coming in, and eventually it leads to failure of that structure. So again, all fairly unique. And in this case, they wanted to take lots of LiDAR. These produce fairly large data sets compared to what we're used to. And so there's a fairly big data management issue around the LiDAR. And then they'll look at the progressive damage of the structure. Third and final example, we try to do things as large as possible. So getting to prototype scale, there's a picture of our director, Pedro Lamonaco, for scale. And again, you can see the sensors in this picture a lot more easily. These are pressure transducers that measure the impact of the wave on the wall. So this would be, for example, the wave of a tsunami simulated in the other channel. It's a big, large wave coming down. It's structures, and we do lots of visits, anything from school kids to elected officials. So other examples where we're looking at the impact of debris. So those types of tests require really high sampling rates and things so that we can get accurate measurements of what that impact was like. And then final one is just failure and loss of a structure. These are replicated day after day. So when we're working with some of these materials, the researchers just do the same thing after, one after the other. But that gives you a general idea of the types of testing that we do. Big part is how do we get all of that data to design safe, and then having worked almost 20 years in getting data to a offsite repository, we're pretty streamlined on that. It goes up pretty well. I think the big issue now is what do we end up publishing and who's responsible for publishing that data. But again, being replicated, all the different sites are doing the same thing. The URL to Design Safe is in the lower right. It's more than just a data repository. It helps the entire community. It's kind of like our way of linking together around research. We have a very active community with workshops and so on. So website's great for that. But I am highlighting today just the Data Depot. And this is a phenomenal resource, hundreds and hundreds, probably at this point, thousands of published data sets, ranging from field research data sets, some are social science, some are experimental data sets, but everything is very unique. And so each person has to create their own data structure with help from Design Safe. So I'll just walk through one of those today. This is the example of a data set that was put together by a colleague, Tori Tomasek at the US Navy with our help. And the data set has a data diagram. So each of these experiments are repeated. The PI has to do a really careful job to describe the experiment, what the setup is. We heard a little bit about metadata, how the instruments are configured, and then the events. So this is kind of the repetition of the types of experiments we do day in, day out. And all of that has to be laid out in advance. And it's not a joyous job. Somebody has to do it. Oftentimes falls to the graduate student or the postdoc who's on site. And then, that has to get, there's a learning curve associated with that. And then the next student coming in, the next student coming in. So we've really worked hard to build best practices and how to, make sure that gets streamlined and accomplished in a reasonable amount of time. The data sets are, as I mentioned, they're published under the Creative Commons license. This particular data set, just kind of FYI, is about 60 gigabytes, which is, I would say, kind of typical. But some of them with the LiDAR, they tend to get much bigger. But it's very easy for folks to download the data set and then also to, attribute, cite the data, all that kind of stuff. They can leave comments if they want. And the PI can go back in and update all the metadata. If they published more papers, they can certainly link between the work that they've been doing and the data. So we try to create a really strong link between the journal paper, which motivates the PIs more often than not, and then the data that was used to create that journal paper. Yeah, just again, to give you a little bit of an idea, we run a lot of these experiments, custom experiments every year. This was a pretty busy year in 23. And I would say at least half the people on this list were first-time users of the facility and did not have experience with how to upload and publish their data. So we had to walk them through. You can see the career awardee. So they're, just starting out. They're great to work with, very enthusiastic, but having a plan for how we publish that data is important. We took this on early. So this is a little bit older slide, but pre-COVID, we were learning from Design Safe that it took almost 2 years from the end of our testing to get the data published. It was a very long time in the scheme of things. Like, people want to have access to the data, and we weren't sure why it took so long. A lot of people just kind of waiting until last minute, or the grant is ending and they kind of somewhat hurriedly publish the data, and some data sets were not being published at all. So we were in the midst of several projects when we learned that our data just wasn't getting published quickly enough. And so we took it upon ourselves to talk to the researchers for each of these different projects. What will it take to get them to commit to publishing their data? And so we worked with them, we worked with Design Safe, and we were able to cut the time from about 2 years to about 3 months. And so I think a lot of it had to do more with the people than, just kind of the available technology, just kind of working on a process to get it published. We learned a lot through this. We built some best practices. We asked the researchers top 3 things and so on, like what worked well, what would you do differently, do's and don'ts. We've held some seminars within the NHERI community to try to educate people and share these best practices with the other sites. We have a full appendix with all the feedback from the different people. But just to give you a rough idea, these were, ranged from assistant professors, postdocs, full professors. Kieran listed here was a graduate student at the time. So we tried to get a range of people and feedback on what seemed to work and how we could improve. And, one of the biggest responses was working directly with somebody who's a professional in data archive. So that was Maria Estevez on the Design Safe team, having open office hours, not having to worry about arranging meetings all the time. You can just show up and get some really good tips on what to do. So the office hours were a huge help. And I think I'll highlight maybe 2 or 3 of the things, but the emphasis on starting early with a plan, even during the experimental phase, rather than waiting until the data is collected, we really have to get our users thinking right off the bat on how they're going to publish their data. And I think the second one that was really key was not to try to publish everything all at once. That I think it's almost overwhelming after 2 or 3 months here, how much data there is to work with. And so trying to work with the PIs on publishing almost in the way that they publish their journal papers. So just pick off portions of the data set that you think are most important, at least get that done, rather than, this giant boulder that has to get moved. So really just trying to chunk, pull it out in chunks, really, that the PI finds useful. I think, I think this is almost a repeat. It's really just having a plan. This aspect of a DOI turned out to be really interesting. I think the idea that, especially for early career faculty, that this is something published and something that they can get credit for was seemed to be a pretty big motivator. So in the end, this is getting to my last slide, second to last slide. This was our old model. This was the PI coming in. This was their timeline. Next timeline down below was us. And then we would just work with them right before the experiment started on their data. And then right when they left, here's all the data, it's on Design Safe, you take it from here. That was kind of our mode because we had another project coming in, like probably about, within a few days, we had another team coming in. And so we felt our job is just pass off the data. But it turns out it wouldn't get done. It would take a couple of years. So what we started doing was really creating this three-legged stool, if you will, like being that middle person to get the PIs connected with Design Safe team and then have follow-ups. So after the experiment is over, really being involved in that publication process and checking in with the users periodically to just see how they're doing and just kind of emphasizing the importance of getting that data published. So I think rather than leaving the data with them, it didn't take that much work for somebody on our staff to keep in contact with the research team that was using our facility until that data was published. And I think that's kind of the main things I wanted to talk about, just kind of sharing the experience that we had here. I would say overall, we've had a huge uptake in getting the data published. And I think at this point, things are pretty streamlined, and we feel really comfortable at the rate that the researchers are publishing their data.